Hi everyone, Vladimir is here with our multi-platform game development tutorial part 14. And today we're going to continue polishing our game. So to do this, I think we're going to add screen shake and our characters are going to appear, smoothly on the screen. I think we're going to try doing that. So first things first, let me get back to my desktop. Here we are. And right, first thing I want to say is that I fixed bug when our bonuses kept spawning onto one onto the other. So we have our for cycle wrong in our game logic spawn random bonus function. We should target non-empty should be false, so that the for cycle will go through the fields while we have not found anything. As soon as we find a bonus that covers our existing player or existing other bonus, we should stop. So yeah, here we change the condition to be target non-empty equal false. After that, let's get directly to our screen shake. We're going to shake the screen after the player has taken damage, so we definitely need to record when the damage has been taken. Let's make the getter function inside of our character class. So it should be a simple getter, public float get time of damage taken and return time of damage taken. This one is first, and then we also need to know how long does the player has been alive, so we also need another getter, get time alive. Return time alive. We will compare the time alive to time of the damage taken, and if not much time has passed, we will commence the shaking of our screen. So in our game screen class, let's create a new variable, or rather a constant. Let's name it shake time on damage or something like that. Public static final float shake time on damage. And let's shake the screen for 0.3 seconds. Empirically, you are free to adjust everything. It's your game, not mine. You actually can use this code wherever you want to. Static final, and another variable we need to, determine the shake distance, how much the screen is shaking from one side to another. So make a constant shake distance from my empirical calculations and experience. 4 should be enough. 4 pixels should be enough for this case. So what are we gonna do when we update our camera? We should actually update our camera in our draw UI call. Right before we draw UI, we should set the camera position. Game stage get camera position. We should set the position to be the middle of the screen like it is now. So we just take the game stage get width divided by 2, and then we get game stage get height divided by 2, and then we keep 0 as z coordinate, and game stage camera. Basically it will do nothing now. Let me just launch and show you. Nothing is changing. What we're doing, we're centering the camera on the screen so that we are sure that the camera is back to the center of the screen during every frame. So right now it doesn't affect anything, but here's the catch. If our player lives are greater than 0 and the player has recently taken the damage, we just take time alive, subtract time of the damage taken, and if it's lesser than the shake time after damage, we simply get our camera and we translate our camera, meaning like doing a little shake by shake distance divided by 2. It's to ensure that our camera can go left and right equally, and we just add the random number of shake distance. And do the same with y coordinates. shake distance by 2 plus markUtils random shake distance. Change it by 0 on Z coordinate, and right now let me show you what's happening. As soon as player takes damage, we see that the timer has passed, and the screen will start shaking if the player... See, the screen shakes slightly after the player takes the damage, which to me looks pretty cool. Let's heal up and take the damage one more time and actually feel how awesome we are for implementing the screen shake. But that shouldn't be it. You know, as we run the game right now, the enemies just suddenly stand there, as well as the player. I think we can fix this by making the player, you know, appear out of the left screen. It's like he's running, and then he encounters the enemy and fights him. So what we're gonna do, let's go to our player Java class and implement a static final float variable which will indicate how long the player is approaching. Approach time, actually make it public in case we want to freeze the controls during the approach stage of the player. But basically we have the first 0.5 seconds of the game, the player is going to approach from the left. And this should be pretty simple. We just modify our draw function. If time alive is less than approach time, then the player is going to be approaching, else we just set position as we did before, and no harm done. This thing remains the same as it was. But while the player approaching, we will use the easing function, the same one as the previous time, the quadratic easing function. We take the time alive divided by approach time, and we get something from 0 to 1. Then we square it, and after that we set the position of the player. We just copy and paste the previous line of the setting position. It sets the position. The Y position stays the same. We still use size evaluator. For X we do still use size evaluator, but we multiply it by our T value, which is going to be from 0 to 1. So this will ensure that the player gradually appears from the left side and goes to the right side. You see how it was now? To make it a bit more observable, I'll just increase it to 2.5 for you to see what's going on, and we'll run the game. You see, he slowly approached his coordinates. So that's how it's done. Still, approach time is still 0.5, got it back, and for the enemy we should, for the sake of exercise, make the enemy appear out of scaling. He's small and then he grows. That's what I want to do. And how do we do this? Apparently, the similar time as with the player, we go to our enemy class, we introduce the private static float resize, or rather scale time. It will be half a second. Same with the player approaching. In our draw function, everything keeps the same. We still set position, but if our time alive is lesser than our scale time, we're going to scale our player accordingly. But if the enemy accordingly. But if the enemy has been alive for more than half a second, we just set scale to 1. We actually can skip this line, but I always want to make sure that everything is fine. So set scale, we create the same variable t. Basically it's the time that has passed. We set it from dividing the time alive to scale time, ensuring that it's from 0 to 1 again. Then we square it, and after that we set the scale equal. And now let's see what's going on. As you can see, our enemy just grows. Alright, let's switch it again. See? I think that's pretty cool. I think this does it for today's lesson. I'm just going to commit the changes. And I suppose I'll see you guys the next lesson. Thank you very much. Check the links below and feel free to contact me if you have any questions. And yeah, see you guys in the next lesson. Vladimir is out.